Okay, here is a wrap-up of the Inelastic Collisions Lab, and it doesn't close until 11:45 tonight. So if after this wrap-up you want to change some answers, you can resubmit a revised lab. And I also want to mention that in case you missed it, there are 3 pages to the lab, so make sure that you do all 3 pages. If you don't do the last page, you will only get 2/3 of the credit. All right, so here's a wrap up. Important things to know, that in a closed system, the momentum before the collision equals the momentum after the collision. I'm not sure why, but they're missing like the total. So this is total momentum of all the objects that are traveling before is equal to the momentum of all of the objects traveling afterwards. And so in order to solve collision problems, you want to calculate all the momenta before and add those together. That's your P initial. You want to calculate all the known momentum after. That's your P final. And then you set those equal to each other, and then you solve for the unknown variables that you're looking for. So let's do an example. I've got a green ball, M, collides with a red ball of mass M2. M1, M2, and we know that total initial equals total final. And so we're just going to do the equation. Now this is the 3rd or 4th time you've seen this equation, and several of you look at me blankly when I ask you about it. So you might want to write this down or reference it so that you don't forget this equation, because I'm not going to tell you what the equation is. You need to put it in your notes. Okay. All right. So this is my initial. So I've got mass 1, initial velocity, mass 2, initial velocity. So that's my momentum initial. And then my momentum final is mass 1, final velocity. That's momentum final of 1. And then momentum final of 2 is mass 2 times its final velocity. And actually, I don't even think you need to memorize this equation. If you just know that P is equal to mv, then you just add the P's before and the P's afterwards. So. Okay, so in this collision, the red ball is initially at rest, and so which term can we get rid of in this equation? And if you knew the answer was this one, that is correct, because the velocity is equal to 0, and so anything times 0 is equal to 0. So that simplifies the calculation a little bit to make us able to do this. So the balls stick together after the equation. How do we show that? All right, and again, I think you've seen this as well, because I'm pretty sure that I showed you this equation. But if they stick together, that means I have a single object that is m1 plus m2, and they have a single velocity. And so let's go ahead and solve this problem mathematically using this equation. So a green ball has a mass of 5 kilograms. Now, you know me, I like to make annotated pictures, and I highly recommend doing that. So I've got and I'll even color code it. So I've got my 5 kilograms and moving at 10 meters per second. And then it's coming to red, which is 15 kilograms. So what is my total initial momentum? All right, my total initial momentum using that equation is going to be 5 kilograms. Oh, I should do this in green. Is going to be 5 kilograms times 10 meters per second plus 0. And so 5 times 10 is 50 kilogram meters per second. So that is my initial. and then the balls collide and stick together, what is their resulting velocity? So I want you to use the equation. I'll draw the picture for you. So I've got 5 kilogram, and I've got 10 kilogram. Nope, 15 kilogram. And then they've got some velocity. All right. So fill in everything you know in the equation. So I know my P initial is 50 kilograms. And what is going to be M1 plus M2? That is going to be 20 kilograms. And then I'm going to have my velocity. So what's my velocity equal to? And that's V final. All right, let's see if you got it. Okay, so we end up with 50 kilogram meters per second divided by 20 kilograms. The kilograms cancel. I end up with the unit of meters per second, and it's 2.5 meters per second. Hopefully you got that. All right, now time for some work. Define a perfectly inelastic collision. So in a perfectly or totally inelastic collision, the two objects stick together after the collision. There's only one final shared velocity. If you just said they stick together after the collision, that's good enough to get 100% right on this. All right, a 10 kilogram puck moving with a velocity of plus 3 meters per second strikes a second stationary 10 kilogram puck. The pucks stick together after the collision. What is their combined velocity after the collision? So this is just like the problem we did. I expect you to be able to calculate this. All right, so we've got M1 V1 initial plus M2 V2 initial is equal to M1 plus M2 times V final. And we know that that is 0. And so I'm going to solve for my V final. I've got M1 V1 initial divided by M1 plus M2. I'm going to plug in my numbers. Ooh, I didn't draw a picture. That's all right. So I've got 10 kilograms times 3 meters per second over 20 kilograms. And that is going to be my V final. Those cancel. And 10 divided by 20 is 1/2. 1/2 times 3 is equal to 1.5 meters per second. That is the answer. And that's also what people who wrote this think is the correct answer. Okay, so notice the moving mass doubles, so the velocity is half as big. And you might have been able to do that from the lab. Okay, what is the kinetic energy of the system before the collision? So let's calculate that. So kinetic energy before the system, only object 1 is moving, so that's going to be 1/2 M1 V1 initial squared. And so that's going to be 1/2 times 10 kilograms times 3 meters per second squared. Okay, so 3 squared is going to be 9. That'll be meters squared per second squared. And then times 1/2 times 10 is 5 kilograms. And so 5 times 9 is going to be 45, and the unit is actually joules. So kilogram meters squared per second squared is a joule. What is the kinetic energy after the collision? So after the collision, I've got 1/2 times 20 kilograms times 1.5 meters per second squared. And I can't do that one in my head. 1.5 squared times 20 divided by 2. So I get 22.5 joules. Okay. All right, so we got 45 is correct. After the collision, 22.5 is correct. Was kinetic energy conserved? And the answer is no, because these are different. In order for a quantity to be conserved, you have to be the same before and after. Now, did the energy go away? No, it went into things like thermal energy, the energy of bonding. Like on the carts, you can hear the Velcro stick together, so it goes into energy of sound. So the energy doesn't disappear, it just goes into different energy accounts. Okay, so for positive physics, you are going to do complete problems 1 and complete problems 2. You will be able to do this. Watch the video if you want some help. The one thing that I want to emphasize is that when you look at the impulse, this is equal to the change in momentum of a single object. Change in momentum of a single object. So if you have 2 objects and one object loses momentum, 2 objects colliding, one object loses momentum, the other object has to gain the exact same amount of momentum. So I'm just going to make up some numbers. Suppose we have a ball moving along, and it has a momentum of 20 kilogram meters per second, and then it collides with a stationary ball. So this is before. And then after, this ball is now going to the right at 20 kilogram meters per second. So that'll be a negative. That means that it actually had a change of minus 40 kilogram meters per second, because final minus initial. So this is my final. Okay, so final is minus 20. I'm just going to do numbers. Minus the initial is 20 is equal to minus 40. So this is my change in momentum, or my impulse. And so that means that my stationary object now has to go this way, and it's going to have a change of it's going to have a momentum of plus 40 kilogram meters per second. So P initially 0. So this one lost 40, this one gained 40. And that's why on positive physics you'll see the absolute value of the J is equal to 40 kilogram meters per second. So whatever one gains, the other loses.